everything starts from data, and data has a huge heterogeneous source, and you can go from sensors, data acquisition, IoT to cloud, and you could create, edge computing devices, and you can create fog computing devices. All of that is another reason why you really don't have data. Very often you say, I have a lot of data, but once I start looking at the data, either the key data is missing or the data is not connected. You have one data over here, the other data here, the third data here, but they're not matched. Just talking about a major steel manufacturer, and I'll not say the name, but I'm sure you all would know whom I'm talking about. They make steels, they make steel rebars, they also make cement, they also make paints, and all of these companies have their own ERP systems. As a matter of fact, when they were growing, they acquired tons of other small companies. Now their flat products had 9 or 8 facilities, and each have been acquired by taking over some other company. And each of those companies have their own ERP system. Within one company now, they have some 6 ERP systems running, and those ERP systems don't talk to each other. So the customer of site 1 is also a customer of site B, but they don't know that. So your data is not connected. So you may have lack of data, or you may have disconnected data. And if that is the case, that is as good as not having data. Now the solution is not to come up with a bigger ERP system, say, oh, I'll deploy SAP for all your 8 facilities, create one master big ERP system. Then what will you do the next time when you acquire some other company? You'll again pay to SAP to do the merger of that, because the tables, the columns, the databases, the data architecture is completely different. You may have 2 extra columns here which are not there. They may be having tables over there which you don't even record. You can't just merge those things. And what is the way out? XGen. You have to have an expert generative AI which will be able to look at all of this heterogeneity at a ground level and give you a cohesive single view image at the end of the day. So you don't need to really have all those queries. For you, it will be as if it's a single database, but all the internal databases are fragmented. And that brings the aspect of big data. So we are very soon moving towards big data in almost every area. Each of us carry a phone. Big data has hundreds of definitions, and it keeps changing. Why? Because the size of the data which you can store keeps changing. But so does the size of data generation keeps changing. So I say that you have reached the level of big data if you realize that your data center cannot store data and you have to delete it. Do you have such a data center? As a matter of fact, all of us does. We have our cell phone. You have to delete images, right? You have to stop videos. If you want, you can start taking videos continuously. And how long do you think your storage will last? How long will your bandwidth let you put this in cloud? You'll soon realize that the storage and bandwidth has already lost and data creation has already won. And that's where you have already reached the big data stage. And every company, every organization will have their own specific limits, and of course you can push it a little bigger or smaller, but you will have those. So what you have is that you have a huge volume of data, you have a huge velocity of data. Data is not stagnant, it's flowing, it's changing every minute, and it has a huge variety. You have text files, tables, images, videos, sensor data, complex data structures, and finally, a lot of such data has wrong stuff in it. People labeled something incorrectly. They said this, but they have labeled it wrongly. So you have a lot of data. When you have large terabytes, petabytes of data, hundreds of terabytes and petabytes of data, you will have a lot of data which is incorrect. And you should be able to handle all of this, and the AI should be able to work with that. And that is where you need systems which can work with that. And machine learning comes to your saving. So now you have primarily, and I want to just quickly give you a sense, and you could probably relate it to your organization. You'll have 2 kinds of data available in your organization. One will be a data where there'll be an input and an output. So maybe you are doing coatings, you are creating galvanization, or you are making rods. Cold rolling mill is creating rods, or you're creating sheets, or you're creating a part. You're machining something, you're casting something, forging something. Something you're doing, your production facility is doing something. And you have an input data of what you have input. It could be the man hours, the material, the process parameters, and you know the output. And the output could be the quantity you have produced, the quality of it, what defects you had. So this is a very common data which we all have. And whenever we are asking and thinking of data and thinking of applying AI, we look at this. I have this input, I have this output. Can I predict the output given the input? The answer is yes, of course you can, and that's where machine learning comes, and that is where we call this part as supervised learning, where you supervise the machines based on the input and output. And those are the two kinds of supervised learning: regression and classification. Now, using this, you can predict what your quality will be, what your production will be, what the demand of your customers would be, and things like that. This is based on data where you have an input and output. This is a very large amount of data which you have. But at least 10 times of this data is another kind of data, which is just an input data. You just have data. You don't have it related to any output. You have lots of stuff happening, but what do you do with that? You all are sitting here. I have all your images. You all are maybe doing something. I have that data, but there is no output which I have to relate to it. What do I do with that data? Is that a waste? Well, to humans, we cannot even fathom as to what to do with that. Here I said, input, output. I want to improve my output. What should I do to my input? But here I have just a lot of data. There's no output. What do I do with this? Well, we humans do have some understanding of this. So I'm looking at you. There is no output. It's just data. And I see that you start having some boredom set in. And I realize, oops, what I'm saying is probably not very interesting to you all. So I can comprehend something out of it. But basically, what happens is that there's a lot more data which we have where we do not have an output. And this is where unsupervised learning comes into play. Unsupervised learning is where you don't need to tell an output. You just have to give it a lot of data, and it starts seeing pattern in that data. This is something which I call as the second type of ignorance. We have two kinds of ignorance. One is type 1 ignorance, where you know that you don't know something. So if I ask you what is the process of creating, let's say, a single crystal turbine blade, you know that you don't know how to do that. If I ask you what is the way to produce a nanometer IC, you know that you don't know. But that's all right, because you know that you don't know that, so you can go to an expert and ask. You want to start a carbon fiber manufacturing facility, you don't know how to do that, but you can go to an expert and ask. You can go on Google and search. This is the first kind of ignorance. Ignorance of what you know you don't know. But then there is a more dangerous kind of ignorance. The ignorance of the type 2, which is you don't know what you don't know. You don't know that. Now, I'm asking you, please go and search online on something which you don't know. Now, the moment you start searching for it, you know that you don't know that, right? How do you search for something which you don't know? And that is the most dangerous kind of ignorance, the ignorance of type 2. And that is what is being taken care of AI. So eventually, moving forward, AI will generate patterns beyond questions which we can ask. This is where we could ask questions. This is data where we don't even know what questions to ask, because we just don't even know what to look for. But AI will be able to generate that. And that is the second kind of ignorance. You don't know what you don't know. And thus, AI has such a powerful methodology of breaching these gaps. Now, coming to more specific areas of some of the applications which I'll quickly show you. So, for instance, you can, in machining process, we have used a lot of AI to predict chatter. Now, chatter can lead to surface degradation, quality problems. And you could use chatter to predict, you could use AI data and AI to predict when chatter is about to happen. And this is not really true prediction, because this is actually more of diagnosis, but it can happen in real time, in less than 250 milliseconds. So that you hardly have one round of chatter and you are able to correct for it. And thus your part doesn't require any rework. You can also do lots of other kinds of things, and we have worked with jewelry industry to predict gas porosity in your gold rings and predict how we can decrease that using AI. We have looked at demand forecasting of jewelry. So you go and buy jewelry more on few days and then you don't buy at all. So there are some peaks which you see. And if you know what jewelry will be sold tomorrow, which size of ring, which caratage, which style, then you'll stock that. And gold is a very, very expensive thing. You invest crores to stock the wrong stuff and it doesn't sell, you really lose customers. Also, you just lock your money in that. So we have these models, and some of the work is published out. Other work is with industries, which I can just talk what I'm talking. I can't even tell you the industry. This was with the MITI. So this is a government funding. This is published work. We have one of the most advanced models for that. This is a Czech company which also has a manufacturing facility in India for creating low-pressure die casting alloy wheels. They wanted to look at the defects which are being caused in this. This goes into one of the world's most prestigious truck manufacturers in Europe. So they wanted to see where are the porosities, and they have 16 blowholes from where they can start cooling and all sorts of things. So it's a very complex space in which you have to run this. And this is not possible for me to have huge data because they always had data in a very narrow band. And that's where we used XGen, expert generative AI. What it did was that it started running finite element simulations itself. So the AI became like an advanced researcher. It ran finite element simulations, learned from it, calibrated it based on the limited data which it had, and then it was able to predict how the porosity will come and what you need to do to mitigate it. Now, this is something which can go on and on. We have also done something for another industry in US which makes inserts, carbide inserts for cutting. And again, they had a huge problem with defects in it, and AI could look at all the complex data and figure out. A very big problem over here was that the defects were labeled, but they were labeled in a very strange manner. So you produce a part, and the guy who's producing is also required to label it as to what is the wrong with it. And now what happens is that the person is just too busy in producing, so the person does not label it. And once he has produced his shift, after that he says, oh, I have 150 bad parts, he labels them all. This is an edge overflow or a flash in all of them. Or this is something which is a burr formation in all of them. So all the defects are of the same kind. And we were like, how is this possible? Suddenly all the defects in this shift is of just one kind. Then we soon realized that this is the problem because the guy is not really looking at that he has to record. Every time he finds 8 hours of shift, he finds a problem, he writes that. He will write 150 different remarks. He just writes one remark and says same for all. So there's a lot of input which really is wrong, and how you take care of that. So finally you put it all together, and I'll just close very quickly. It shows time up, but please hoot me down if the time is really up. You don't want me to speak a little more. So this can be all put together in a digital twin. A digital twin is a concept which is very time abused. People just everything and anything is a digital twin for them. So you make a 3D model, you call it a digital twin. You run a simulation, you call it a digital twin. You pretty much can call anything a digital twin because there is no such formal definition, although there's an ISO standard which says what a digital twin should have, but it's so vague as well that you could still be complying with that ISO standard and not really have a real digital twin. So for us, a digital twin has 6 dimensions. First dimension is that it has a physical space. So you have a machine, but more than machine, you have a man, machine, and environment. All of these things affect. And that then communicates with a CAD model, which is a 360-degree model, through IoT, OPC UA, MT Connect, and other protocols. And then all of this data is given to AI, and AI on demand can run physics-based, engineering-based models. So it can run AI simulation. AI can run engineering simulations. So it has all the engineering domain knowledge available to it. Then it also has knowledge of what is happening in the world. So it can talk to other machines, which is a machine-to-machine communication. It can also talk to humans, but it can also talk to the World Wide Web. It can look at what is happening in the world. And once all of these things happen, that's when your model becomes a digital twin. And that digital twin, in a sense, is an advanced worker who's fully aware of the past, present, and future and can take informed decisions which are as per organizational objectives. So the only thing you have to tell, this is my objective, and it will make all those decisions. So it knows that there is a possible escalation of war further in the Middle East, or Ukraine war will continue, the gas prices will go high, and thus you need to stock something in advance. This supply chain comes from this country which will get affected, or this will be needed because this is required. So it can do all of those things for you. So now I'll just quickly show you 2 digital twins, and maybe, so this is one such digital twin. And I'll show you a live demo of this rather than this. This is a 5-axis DMG Mori machine. And then you can put these digital twins together to create a digital factory where you have connected digital twins. So what you really can create is you can create machine digital twins which are digital twins for a high-value asset, And once you create many of these digital twins, you can connect them to create a factory digital twin where every aspect going from one station to the next station, from one shop floor to the other shop floor, you can track machine, data, and material. And thus, you can create digital threads. And what it can do, it can reduce your scrap, it can reduce your losses, it can reduce your downtime, it can increase your throughput, it can also reduce your carbon footprint. Now, it's not really possible to have a piecemeal approach where you do this from somewhere, you do this from somewhere. Imagine you have a system where there are 20 different things being supplied by 20 different pieces or 20 different companies and they don't come together. So we feel it's extremely important that you put it all together in one cohesive manner. And what it all is that it starts with, of course, it starts with data. It starts with data. And you get the data from SCADA, ERP, IoT devices, or IoE devices, Internet of Everything, or human-machine interfaces. And then you feed it to models, AI models, which are having advanced engineering. And then finally, you create digital twins for them. And there are lots of such available models. This is one of the key technologies, a proprietary technology of ours, which creates IoE, which we call Internet of Everything, which can extract and write data to any Windows application, even if that application does not provide an interface to be used for reading and writing. It can also transmit this data securely to the cloud, even if your computer is not connected to the cloud. And then, of course, we have another proprietary technology for machine vision, which we call as AI visionetics, where we have hierarchical model, where models look at multiple layers of AI, and thus one AI creates a metadata for the next level of AI, and that metadata is trained on the next level of AI and it's taken to the third level. And in this way, you can have very complex models created with very limited data. So the training is reduced phenomenally. And thus, basically, you go through the journey, not just for remote monitoring, but smart diagnostics. But once you diagnose, it's too late because the problem has already happened. So you want something which is predictive. So you can predict before the problem happens, and these AI models can predict what is about to happen. Because once it has happened, it's a little too late. But prediction is not good enough. Okay, you predict you are going to have diabetes in 2 years from now. You tell me what to do. What should I do? So you have to prescribe. So AI model has to go from all the way from monitoring, which is what most of the current things do, to diagnostics, smart diagnostics, predictive analytics, but prescriptive analytics. You have to also tell what's the solution. Don't just tell this problem will happen. That's not good enough. But very often these solutions have to be also implemented back in the shop floor. And that's where you have the entire circle which comes in, where AI, machine control, artificial intelligence takes control of your machine itself and can bring this entire thing in one shot. And this is how it works. So this is your shop floor in the dotted region. The data from humans, your ERP systems in the shop floor goes to AI, IoT servers. IoT servers goes to the AI workstations. You have model zoos which feed the model, AI models to it, and then that could be shown as a dashboard. But dashboard is not good enough. It should actually be able to give a direct controller command where the controller can take over, the AI can take over the controller and then make a corrective action. So this is something which is really possible. So in this entire chain, this is how you can have, AI can be there in every aspect, and I just talked about the aspects of which is more to do with production and manufacturing, but you have AI in all aspects it can be working.